So what is an asymptote? What is an asymptote? What is an asymptote? Okay, so guys, asymptote is a line which continually approaches towards your curve to touch it, but it never ever touches it. At least at the finite distance, it will never touch it. So what is an asymptote? A line that continually tries to touch the curve but never touches. At least at the finite distance, it will never touch. At infinity, if it's touching or not, we don't know. But ideally, it's never touches. It never ever touches. Okay, let's take some examples. Let's say we have an equation. Let's say we have an equation 10x minus 2 divided by 5x minus 25. Y equal to this. So this is a rational function. Now if you observe, 5x minus 25 can never be equal to 0. Denominator can never be equal to 0. Why can't a denominator be 0? Because if the denominator is 0, the whole function will not be defined, right? Anything divided by 0 is not defined. So this means that 5x minus 25 is not equal to 0. Okay, which means 5x is not equal to 25. What did I do? I shifted minus 25 on the right hand side, which means if I shift 5 on the other side, on the right hand side, x will never be equal to 25 divided by 5, which means x will never be equal to 5. X will never be equal to 5. Now x cannot be equal to 5. So x equal to 5, can I say x equal to 5 is a line which is parallel to y-axis. This is a line which is parallel to y-axis and passes through 5, 0. So this line over here, x equal to 5 will be a line which we will call as a vertical asymptote. Okay, so this thing over here, x equal to 5, is vertical asymptote. Okay, now we'll just graph the function and we'll understand what I mean by this. So look carefully, the function is 10x minus 2 upon 5x minus 25. So the function is 10x minus 2 divided by 5x minus 25. Now if you observe the function, if you observe the graph, it looks something like this. Okay, now I'm going to draw that line. Which line? I'm going to draw the line x equal to 5, which we called as a vertical asymptote. Now if you observe this line, okay, I'll just change the color. I'll make it red. Okay, now if you observe the red line, I'll hide this. If you observe the red line, okay, I'm just going up. If you observe, it's trying to touch the curve. The red line is trying to touch the green curve. Now at this distance, you will say, sir, the line has touched the curve. But if I zoom it, what's happening? The line is not touched. Again, you go up and up, right? You just go up. Like you can see on the left, the coordinates are 116, 117, and then we are going up and up. So we have reached almost 162, 163. You can go up even more. Now if you see, the line is coming closer to the green line. The red line is coming closer to the green curve. We are at 244, 245. If we go up a bit more, you will see that the line might touch, but if you zoom it, it won't happen, right? The line is just coming closer and closer, but it's not touching. So basically this line over here, this red line over here, is known as vertical asymptote. This red line over here, if I zoom it out, you will see that it's touching at 60. If I zoom it out, you will say that the line is touching the curve at y equal to 60, right? At this point. But if I zoom it at 60, you see there is a lot of difference. There is a gap. It's not touching, right? So this line over here this red line over here is your vertical asymptote. This red line over here is your vertical asymptote. Now guys, let's try to find the inverse of the function. Okay, so we had a function f of x y equal to 10x minus 2 divided by 5x minus 25. Okay, now let us find the inverse. How do we find the inverse? Swap the variables. So x equal to 10y minus 2 divided by 5y minus 25. I have made a video on inverse function, so you can, maybe if you don't know, you can just go and check it out. Now guys, if you observe, again, the denominator can never be equal to 0. The denominator can never be equal to 0. I mean, even before we find the function, the denominator can never be equal to 0, right? So can I say over here that 5y minus 25 can never be equal to 0? 5y minus 25 can never be equal to 0. Is it correct? Oh, let's say we'll find the inverse first. We'll find the inverse. That's a better call. That's a better call. So that our answer is not wrong. So let us find it. So x times 5y minus 25 equal to 10y minus 2. Okay. So 5 times xy minus 25 equal to 10y minus 2. So 5xy minus 10y equal to, this is 25x by the way, I forgot to multiply this x. So 10y equal to, shift this on the other side, so 25x minus 2. So if I take y common, I get 5x minus 10 equal to 25x minus 2. So y equal to 25x minus 2 divided by 5x minus 10. Okay. Now again, the denominator can never be equal to 0. The denominator can never be equal to 0, which means 5x minus 10 can never be equal to 0. So 5x can never be equal to 10. So x can never be equal to 2. 10 divided by 5 is 2. So x equal to 2 is again an asymptote, but for the inverse function. This is your f inverse of x. This is your f inverse of x. So if you draw the inverse graph, if you draw the inverse of the function that we had earlier, in that inverse function graph, x equal to 2 will be a vertical asymptote, right? But if you remember, in the inverse functions, I have already discussed that x becomes y and y becomes x, which means the vertical asymptote becomes the horizontal asymptote and the horizontal asymptote becomes the vertical asymptote. Okay, so basically x equal to 2 on f inverse graph is a vertical asymptote. X equal to 2, which will be a line parallel to y-axis. For f inverse x graph, it will be a vertical asymptote. But for fx graph, for the graph of f of x, right, this x equal to 2, you have to swap x and y, right? You have to swap x and y. So x equal to 2, which is your vertical asymptote, will become y equal to 2, and again this will be horizontal asymptote. What I'm trying to say here is, if you have to draw this on the graph of fx, then you will have to swap x and y. So y equal to 2 is horizontal asymptote. Don't worry, you don't have to get worried. After 5 minutes, I'm going to discuss some tricks for you to understand how to find horizontal and vertical asymptote. But for now, let us graph y equal to 2. Okay, let us graph y equal to 2. So now I'm graphing here y equal to 2, and we are having a black line, right? So if you observe the black line, again this black line is continuously trying to approach the curve and trying to touch it, but it never touches. Okay, if you observe, now you will say at x equal to 80, 85, 90, 95, it's touching, right? It's touching, it's touching, it's touching. But no, if you zoom it, if you zoom it a bit, if you zoom it a bit, you can see that they are not touching. They are not touching at all, right? So this black line is known as horizontal asymptote. This black line is known as horizontal asymptote. So basically, my whole point of doing this was just to let you know what is a vertical asymptote and what is a horizontal asymptote. We can have an oblique asymptote as well. We can have an oblique asymptote as well. So now let us learn how to find vertical asymptotes. Okay, how to find vertical asymptotes. Vertical asymptote. So it's very easy. It's very easy, by the way. Let's say you have a function. Let's say you have a function fx over gx. Fx over gx. So how to find the vertical asymptote? How to find the vertical asymptote? Always equate the denominator to 0. Always equate denominator to 0. So equate g of x equal to 0. And once you do that, you will get the vertical asymptote. You can have one vertical asymptote, two vertical asymptotes, 3, 4. It depends on the equation. It depends on the equation. For example, let's say you have 10x minus 2 divided by 5x plus 15. Let's say this is your function. This is your function. So this is your rational function. How do I find the vertical asymptote? How do I find the vertical asymptote? Equate the denominator to 0. Equate the denominator to 0. So 5x plus 15 equal to 0. Okay, shift 15 on the other side. So you get 5x equal to minus 15. Shift 5 on the other side. So you get x equal to minus 15 divided by 5. So x equal to negative 3. X equal to negative 3. So x equal to negative 3 will be a line which will be parallel to y-axis and passing through the point minus 3, 0, right? So this is how you find the vertical asymptote. If you want, I can graph it and I can show it to you. So the function is 10x minus 2 divided by 5x plus 15. The function is, let me erase this. The function is 10x minus 2 divided by 5x plus 15. Okay, so this is how the graph look like. This is how the graph looks like. Now x equal to minus 3, x equal to negative 3. So if you see, I'll hide these. X equal to negative 3. If you see, x equal to negative 3 is the blue line. Okay, if you zoom it a bit, yeah, you will see that this is the line at negative 3. So if you go down, you will see that this graph is trying to touch the blue line. This graph is trying to touch the blue line, but actually it never happens. I'll probably go again. Yeah, if you see, they're trying to come closer to each other. You can track the y coordinates that are there. If you see, they're trying to come very close, but it never touches. Okay, it never ever touches. I can zoom it out. And same happens on the top also. Even if you see the top, you can track the y coordinates. It's trying to come closer to the graph. It's trying to come closer to the graph. Maybe at this point we are at 26, let's say 30. Now let's say you will say, sir, 31, they are touching, right? But if I zoom it, they are not touching. If you zoom it, they are not touching, right? They are not touching. So this is how you find the vertical asymptotes. Okay. So I'll erase this. Now we'll take one more example. Let's say you have an equation. Y equal to 6 minus x square divided by x square minus 4x plus 3. Okay. How do I find the vertical asymptote? Very easy. Always equate the denominator to 0. So x square minus 4x plus 3 equal to 0. We'll split the middle term. If you split the middle term, this becomes x square minus 3x minus x plus 3 equal to 0. If you want to learn how I just splitted the middle term, there is a video on quadratic function and quadratic equation that I've made. There is a video where I've taught you how to factorize the middle term. You can just check it out and it will help you. Now you take x minus x common from the first two terms, so x minus 3, negative 1 common from the other two terms, so x minus 3 equal to 0. So x minus 1 into x minus 3 equal to 0. So product of two numbers is 0, one of them has to be 0. So x minus 1 is 0 or x minus 3 is equal to 0. So x is either 1 or x is 3. Okay. So guys, x equal to 1, x equal to 1 and x equal to 3. These are not just values, okay? 1 and 3 are values, but x equal to 1 is an equation of a line. X equal to 3 is an equation of line. Both these lines are parallel to the y-axis. Both these lines are parallel to the y-axis. I'll just show you. I'll show you on the Desmos calculator, graphing calculator. So our function is 6 minus x square, and you are dividing it by x square minus 4x plus 3 okay. So I'll just hold on, where is your origin? Yeah, here. So if you see the graph, it's something like this. It is something like this, right? It is something like this, okay? It is something like this. Now if I draw the lines, which is x equal to 1, which is a blue line, and x equal to 3, which is a black line. Let us zoom it, okay, and let me go to the origin. So if you see this blue line and this black line is trying to touch the curve, but will never touch. It will never ever touch. So if you see the blue line, let's go a bit up. Now you will see that the blue line has touched the green line and the black line has touched the green curve again. But if you zoom it, tada, it's not touching. So basically this, these lines, blue and black lines, are your asymptote. These are your asymptote, okay? So how do you find the vertical asymptote? You simply equate the denominator to 0. And that's how you get it. Okay? So now let's go back to our notes. So how to find the vertical asymptote? Equate the denominator to 0. Now let us learn how to find the vertical, Now let us learn how to find the horizontal asymptote. So let us learn how to find the horizontal asymptote. Let's say you have a rational function y equal to fx divided by gx. There are three cases. What are the three cases? Guys? What are the three cases? The first case is that the degree of fx is lesser than the degree of gx. The degree of fx is lesser than the degree of gx. What is an example? The example is x minus 3 upon x square minus 4x. If you see, the degree in the numerator is 1, the degree in the denominator is 2. So the degree of numerator is lesser than the degree of denominator. First case. Second case, the degree of fx is same as the degree of gx. Okay, what is an example? The example is x minus 3 divided by 2x plus 4. Okay, if you see, both in numerator and denominator, the degree is 1. If you see the third one, the third possibility is that the degree of fx is greater than the degree of gx. What is an example? The example is x square minus 4x divided by x minus 3. X square minus 4x divided by x minus 3. So these are the three possibilities in a rational function. These are the three possibilities in the rational function. Now, I'll just make, yeah. These are the three possibilities. In the first possibility, if the degree of fx is lesser than the degree of gx, your horizontal asymptote is simply y equal to 0, which is x-axis, which is your x-axis. Okay, if the degree of fx, if the degree of numerator is lesser than the degree of denominator, your horizontal asymptote will be x-axis. Your horizontal asymptote will be x-axis. If you want to check, you can check. The example is x minus 3 upon x square minus 4x. The example is x minus 3 divided by x square minus 4x. Okay, so this is your, if you see carefully, the x-axis, if you observe the x-axis, the curve is trying to touch the x-axis, or you can say that x-axis is trying to touch the curve, but they never touches. I'm going towards the right. Mark the x-axis. Now you will say that at x equal to 140 they have touched, but if I zoom it, observe 140, it hasn't touched the x-axis. So always remember, whenever the degree of numerator is lesser than the degree of denominator, the horizontal asymptote is your x-axis. The second possibility, what is the second possibility? If the degree of fx is equal to degree of gx, then the horizontal asymptote will be ratio of coefficients with highest degree. What I mean to say is, you see that the degree is 1, right? So what is the coefficient? The coefficient is 1 here. Okay, in the denominator also, if you see, the degree is 1. What is the coefficient? The coefficient is 2. So what will be the horizontal asymptote? The horizontal asymptote will be simply y equal to 1 by 2. The horizontal asymptote here will be simply y equal to 1 by 2. I can give you another example. Let's say if your function is y equal to minus 2x square plus 4x minus 3 divided by 6x square plus 3x minus 4. Let's say this is your rational function. What is the degree? The degree is 2. The highest power is 2. So you check the coefficients. What are the coefficients? The coefficients are minus 2 and 6. So what will be the horizontal asymptote? The horizontal asymptote over here will be y equal to minus 2 by 6. So y equal to negative 1 by 3. Okay. So this is how you find the horizontal asymptote. This was your second case. Now the third case. If the degree of fx is greater than the degree of gx, in this case, you do not get any horizontal asymptote. What do you get? You get oblique asymptote. Okay. So only two cases. Just remember them and solve as many questions as possible. If you have doubt, please post it in the comment section. I'll help you. Now let us learn how to find the oblique asymptote. How to find the oblique asymptote. So you get oblique asymptote. First of all, let's say the function is y equal to fx upon gx. You get oblique asymptote only when the degree of fx, when the degree of numerator is greater than the degree of denominator. when the degree of numerator is greater than the degree of denominator, you get the oblique asymptote. For example, let's say you have a function y equal to x square minus 4x plus 3, and denominator you have x minus 2. Let's say this is your function. Now what is the degree in the numerator? It is 2. What is the degree in the denominator? 1. What is the degree in the denominator? 1. So how do you find the oblique asymptote? Very easy. Let's divide them. Let's do the long division. So x minus 2, x square minus 4x plus 3. So this comes out to be, if you do, okay, by the way, if you have to learn how to do long division, then I have made a video for that also. Maybe you can check it out. If you couldn't find that video, put a comment in the comment section, I'll help you. So this is x times x, so you get x square, you multiply minus 2 with x, so you get minus 2x. Let us subtract them. So x square minus x square is 0. Negative 4x, negative 2x. Minus 4x minus 2x will be minus 4x plus 2x. So you get minus 2x plus 3. And then you multiply by minus 2 here. So you get minus 2x plus 4. And yeah, 3 minus 4 is negative 1. 3 minus 4 is negative 1. So a bit strange. But yeah. So the quotient over here will give you the asymptote. The quotient over here will give you the oblique asymptote. Let us verify. So basically y equal to x minus 2 will give you the oblique asymptote. Y equal to x minus 2 will give you the oblique asymptote. So let us verify. So yeah, the function, okay, I forgot the function. What was the function? The function was x square minus 4x plus 3 divided by x minus 2. So the function was x square minus 4x plus 3, and this whole thing is divided by x minus 2. So wow, how does the graph look like? If you see, it's going down, and then if you zoom it out, oh wow, it's a very strange graph. But let's see what is the oblique asymptote. Let's go up. Yeah, over here. Let me zoom it, and let me draw the line x minus 2 equal to 0. So y equal to x minus 2, not x minus 2 equal to 0. Y equal to x minus 2. So if you observe, let's go up. Let's go up and up and up. Let's go up. If you see, the green line is trying to touch the blue line. They're coming closer and closer and closer. They're coming very close, but I don't think they will ever meet. So now if you see at negative 13.1, I mean, if you see the, not negative, is it negative? No, it's not negative. 13.2, positive, sorry. So positive 13.2, 13.3. If you see, you will see that the graph is coming closer. Yeah, again, if you see here, you will observe that maybe they are trying to touch, but if you zoom it, it's not touching. So that's how you find the oblique asymptote. That's how you basically find the oblique asymptote. Okay, so how do you find the oblique asymptote, guys? It's very easy. Divide the numerator and denominator. I mean, divide the numerator with the denominator, and whatever the quotient is, equate it to y, and that will be your oblique asymptote. Equate it to y, and that will be your oblique asymptote. Instead of long division, you can simply use synthetic division also. That's absolutely fine. Okay, so guys, I hope I helped you.